Okay, welcome back to a new unit. We're starting unit 4 with lesson 1. We're going back in time really to the first unit where we were doing vertex form and graphing quadratics. So right now we're just going to do a little bit of a refresher on what we did in that previous unit and what those different values mean for A, H, and K again, and how we can graph it. So in a little bit of review here of what we've done, we've looked at standard form, which is ax squared plus bx plus c. This standard form is not really that useful for us. All it really gives us is our a value and our c, which is our y-intercept. So we usually take standard form and we're going to turn it into one of the more useful forms, which is either factored form or vertex form. So in this unit, we're not focusing on factored form anymore. We're focusing on vertex form. For factored form, those were our x-intercepts, and that was our previous 2 units. So now going back and looking at vertex form, it's this formula that we were used to from the first unit. That's a bracket x minus h squared plus k. Now remember this negative sign inside of our formula? That does something special to the h and the k value. Also, this h and the k value are important because it represents the vertex. So now, just as a descriptive values for that a, h, and k, we can go back and recall that a is telling us whether our parabola is pointed up or down. So if it's a positive number, the parabola is pointed up. And if a is a negative number, then the parabola is pointed down. That a value is also useful because it can tell me whether I'm dealing with a stretch or compression from the parent function. And for that, we used a line, number line, that would tell us whether we were stretching or compressing. So basically, numbers in between -1 and 1 were compresses. So these were numbers that when I multiplied, I would take that whole number and then multiply it by something like a half or -1/2, and it would compress the quadratic. Stretching are any values greater than 1 or less than -1, and those numbers would basically be multiplying to increase or extend or stretch out that parabola. So those would be our stretches for A and our compresses for A. Now that H is going to be dealing with the axis of symmetry, which is really the line that cuts the parabola in half, which is the x value of my vertex. And then the k is the maximum or minimum value that parabola reaches. So the max height, depending on whether it's a positive or negative a value. Now, whenever we were doing vertex form, it was always important that we were able to define our domain and range. So just as a review of domain and range, domain is us defining what the x values are going to be. So this parabola can fall between, and then we would say what those values are for x. Range is the same idea, but now we're just dealing with the y values. So we would say y is the element of all real numbers, such that y has to be between, and then we would write down what those numbers are. Now we're going to be practicing this. So let's first start off by just writing down our transformations and some of the important points of our equations. So example number 1 says, determine the direction of opening, the axis of symmetry, the max or minimum value, and the vertex of the quadratic function. And then I give you this function here, 3 bracket x minus 5 to the power of 2 plus 7. So we know that when we take this 5 out of the equation, it's going to change signs because our equation has a negative sign in it already. So this h is actually a positive 5. This 7 doesn't change, it's my k value, so it stays as 7. This h and k is my vertex. So already I've answered one of the questions. With my h and k, I'm just going to write this down so that we have it, which is 5 and 7. Now from that vertex, I can determine a lot. So I can determine what my axis of symmetry is actually, which is this question right here. So the axis of symmetry is the x value. of that vertex. It's the line that's cutting that parabola in half. So the x value for the line that cuts it in half is at 5. Whether I'm dealing with a max or a minimum, well, I know the maximum or minimum comes from my k value, and now to determine whether I'm dealing with a max or a min, I need to determine the direction of opening. In order to do that, I'm going to look at my a value and the sign that's in front. It's a positive. Positives mean that the parabolas are open up. So a parabola that's open up like that, this point being the vertex would be the minimum. So for this one, I'm going to say that the minimum value, not the max, the minimum is at 7, positive 7. And also I can write down some other stuff that we were doing before too. I can write down the translations, right? All the different transformations that have happened. So let's do that. Let's practice that. So number 1, if this was out of 4, the first thing would be to state the direction of opening. So this parabola would be pointed up. The second thing would to tell me if that a value is providing a stretch or compression. So the a value being positive 3, when I multiply a number by 3, it gets 3 times bigger. That's going to be a stretch. So we're going to write down that it's been stretched by a factor. Remember that language? By a factor of 3. Our third mark is coming from our h value. So this h value, which is the x value, is at positive 5. We're not worried about that negative 5 because we took it out of the equation when we're describing it. And positive 5 is telling me that I'm taking the parent parabola and I'm moving it 5 units to the right. Or shifted, moved, or shifted 5 units right. Right is telling me that that 5 is a positive. If I wrote left, it would be a negative 4. The fourth transformation that's happening is the last value, which is at positive 7. Positive 7, which is my k, which is my minimum, which means that I've moved 7 units up because it's a positive 7. So remember writing down those transformations from our first unit? That's a quick little review on writing down the important points from that function. Now that we know where the important points are, we can actually use those important points to provide ourselves with a quick sketch of a graph. So right now, example number 2 is saying, throw down a quick sketch of 2 bracket x minus 3 to the power of 2 plus 1. So I'm just going to make a quick grid, and then I'm going to write down what my important points are and the direction of opening. So the most important point is my vertex, which the vertex for this parabola is the h and k, which is at 3 and 1. Remember to switch the signs in front of that h. That's the only important thing that we got to remember there. So now that I know that my vertex is at 3 and 1, I've also got to describe the opening, or at least put that down for a sketch. So I'm going to look at that 2, and that 2, which is the a value, is a positive, which means that it's pointed up. So I'm going to quickly plot the vertex at 3 for x and 1 for y, and then draw a parabola that's pointed up with arrows on the end. Now that's the quickest way to draw a sketch for a quadratic, but now the next part is asking me to define the domain and range. So for my domain, it's my x values. We always going to write down our squiggly brackets, then x is the element of all real numbers such that, and then what we would usually do is put our x in the middle and then put our greater than and less than signs on either side and fill in numbers that are lower and higher if we have them. But now looking back at this parabola here, if I try to look at the lowest and highest numbers for x, well, they go on forever in either direction. To the left and to the right, my parabola has any x values on the left of positive 3 and on the right of positive 3. It'll just keep going on. So can we actually close off or define the domain to a specific set of numbers? No. For this parabola, and for actually all parabolas, unless they're in a word problem, of course, right? If they're in a word problem, then they could be a little bit different because they have to be real time or real height or things like that. But right now, with just parabolas, they're always x is the element of all real numbers. That's easy. That's a giveaway mark. Our range will always have a restriction on it. So our range is our y values, which follows the same format. Y is the element of all real numbers such that. Then we put our y with our greater than and less than sign, and we'll fill in the lowest and the highest number if we have one. So let's go and look at our parabola right now, and we can follow this over and see that the y value of 1 is actually the lowest number for y. But is there a highest? No, because the y goes on forever with these arrows, right? That's because this parabola is open up, and just like the one that we did before, if it's open up, that means that it has a minimum, which is the lowest. So we have the lowest value that we can fill in, which is 1, and we don't have a highest that we can fill in. So we're going to erase that other side. We're not going to use it. Then we're going to remember to close that bracket at the end. Okay, now our next few examples here. The first one is to convert our vertex form back into standard form, which is usually not the norm, but this is just practicing expanding. So when we practice expanding, we were taught some short forms with expanding that we really didn't like. So I'm just going to show you kind of the grade 9 way of expanding, turning it into standard form, which is cool. What we're going to do first is write this bracket out twice, because x minus 5 to the power of 2 means that you write something out to the power of 2 twice. So here it is, wrote it out twice. Now we're going to deal with the stuff inside the bracket. So for that, we're going to use that method from grade 9, which is FOIL, first inside, outside, last. So then we're going to end up with x times x is x squared, x times negative 5 is negative 5x, negative 5 times x is negative 5x, negative 5 times negative 5 is positive 25, plus 1. We'll collect like terms inside the bracket. So we're going to be left with x squared, negative 5x minus 5x. This is my pet peeve that I was telling you guys about at the beginning of the year. It's not 0, it's negative 10, plus 25, plus 1. Now to break those brackets, we'll take the negative 3 that's in front, and we'll multiply it by all the terms inside the bracket, not the 1 at the end, and we'll end up with negative 3x squared, positive 30x, minus 75, plus 1. And of course, at the end here, we can collect these two like terms. So we'll have negative 3x squared plus 30x minus 74. And that's just the easiest way that we can expand and not really learn something new here or try to make it more complicated than it is. Now for this next example, it's going to tell me to determine the zeros, or the x-intercept. So that was the unit that we just did. But if I look at the format that it's in right now, it's in vertex form. That's no good to me, because the only way that I can find the x-intercepts right now is by factoring. And in order to factor something, it needs to be in standard form. So you can go in between standard form to factored form, or standard form we're going to learn to vertex form in this unit. So that means that unfortunately, the first thing I have to do is take this vertex form, turn it into standard form, which is the process that I just did above, and then I can factor it. So let's start off first by expanding and turning this into standard form from vertex form. So x plus 5 to the power of 2 minus 36. I'm going to write that twice. And it looks like the same one above, except that instead of two negative 5s, it's positives. So we're going to have x squared, 5x, 5x, and 25. We'll collect any like terms and multiply by the 1 that's in front, which when multiplying by the 1, it doesn't change anything. So we've got x squared plus 10x plus 25. Oop, I forgot that negative 36 at the end. So let's just bring that down. Then 25 minus 36, we can finish it off as x squared plus 10x minus 11. Now that this is in standard form, now we can convert it, we can convert it into factored form by factoring. So now to factor this, we've got 3 terms here. The first thing that I would try to do always is greatest common factor, but I know I've got a coefficient of 1 at the front there, and I can't take out any x's, so I'm going to use this method of sum and product to make a positive 10 for my sum and a negative 11 when I multiply. The only option that I can have there to make an 11 would be 11 times 1. Now, one of these has to be a negative. It's going to be the 1 because I want to make a positive number at the end, so the positive sign goes with the bigger number. That's all the rules that I've already taught you over and over and over again. So 11 minus 1 is 10. Now, because this is a simple trinomial, we just have to put our 2 brackets, x plus 11, x minus 1. And now our last unit was basically taking factoring and then doing one more step with it. So setting it equal to 0 to solve for the zeros. So x plus 11, x minus 1 equals 0. We'll take that positive 11, bring it over. We'll take that negative 1 and bring it over. And we'll be left with negative 11 and positive 1. These are now my 2 x-intercepts. And that's what we were doing in our last unit. And now we're going to just practice and review writing equations in vertex form when given either a graph or some information. So example number 5 here says, write the equation of the quadratic function in vertex form and then in standard form, which honestly I'm going to save that standard form. We know how to do that. You just expand. But it has a vertex of 3 and 5 and it passes through this point of 1 and 1, which is an x and a y value. Remember that vertex is my h and my k. So if I write down my blank equation for my vertex form, a bracket x minus h squared plus k, it looks like I've got all the values or all the variables except 1. It looks like all I'm missing is a. So let's fill in everything that we know and then solve for that missing variable. So y, I know what it is, it's 1. A, I have no idea what that is, that's what I'm finding. X is also a 1. Now here's where you got to be careful with the negative sign. So whatever you're taking out and putting in always has to be the opposite sign. So right now I'm going to be putting in a positive 3, which means that it's going to look like negative 3 inside the bracket. My k value is positive 5. That doesn't change, so I'm just going to write positive 5 at the end. And then it's just a matter of doing some math here. 1 minus 3 is negative 2. I'm just doing BEDMAS, right? I'm doing brackets, so I did what's inside the brackets. Now I'm doing the exponent. Negative 2 to the power of 2. That's negative 2 times negative 2, which is 4. Now what I'm going to do to kind of make things look a little bit better is a times 4. I'm going to write that a different way. A times 4 is 4 times a. It's the same thing. And now I'm going to use opposite operations to solve. So that means I'm going to take this 5, bring it over to isolate for that a. Then it becomes negative 5 and a positive 1. I got the 4a isolated now. Then I'm going to divide both sides by 4. So right now I've got negative 5 plus 1, which is negative 4 divided by 4. And that ends up being negative 1. Now that I have my a value, I'm going to write my my equation with the variables h and k as variables, like we always do. So y is equal to a, which is negative 1, bracket x, which we leave as a variable, minus 3, plus 5. Now we can practice that and do the exact same thing, or take those exact same ideas with a graph. It's just instead of the points being given to me, what the vertex is, and choosing a point for you, you're going to do it. So let's say what the vertex is. It's -3 and -6. So we can write that down for ourselves. Our vertex is -3 and -6. And then a point, which, you know what, they were nice enough to give us, is at -1 and 2. But you could have chosen any point. You want to choose this point over here, go ahead, as long as it's readable. So another readable point could be down here. These look readable to me. Of these 4 points, any one of them are good. These points here are no good because they're not readable. They don't fall exactly on the line. So I would choose one of these two or one of these two. Okay, so I'm just going to choose the one that's given to us. It makes life easy. So a point is at -1 and 2. So now we have exactly the same information that was given above, but now we got it from a graph. Now I want you to do the same steps that I did here and practice that on your own. If you want to look at the solution, of course, at the end, make sure that you do actually. It's in our Google Classroom in the filled in lesson. That concludes lesson 1 for Unit 4.